at the same time. Is that an oxymoron?
Yeah.
All right.
It's like same difference.
Here we go. I'm going to go slow. What is the secant? What is the tangent? What is the normal? So if I have a curve, and I'm going to draw, what curve should I draw? I'm going to draw this curve. If I have a curve like that, a secant line goes through 2 points. That is a secant. What is a tangent line? A tangent line goes through 1 point on that curve. That's called a tangent. And maybe you've heard of tangents all the time in physics. And then the normal is perpendicular to the tangent. So this is the normal. And I tried to color code as best as I could. Are we okay with that? Okay. So imagine, so again, here's another example. Bird's eye view, so you're in the sky. And imagine you have a basketball tied to a string. So here's that, and you're spinning. So here's that basketball, and you're spinning. Oh man, I tried to draw a perfect circle, but bless you. So you're spinning that way. Are we okay? So if you're spinning that way and you let go of the ball right at this moment when the ball's right here, it will go off on a tangent. It will go off in that direction. If you let the basketball go when it's right here in this location, it will go off in that direction. So those are called tangents there. If you let it go when it's right here, the ball will go off in that direction. See? And you've done that in physics hopefully a few times, right? Okay. If the sun were to disappear, Earth would go off on a tangent because the Earth rotates around the sun, right? Okay, well, maybe for 8 minutes we'll still rotate because for 8 minutes we still see the light. Actually, I don't know, that's a question for your physics professor, but eventually we'll go off on a tangent.
Oh, when you say, like, when you talk a lot and then you change subjects and you say go off tangent, because like you're out of like the rotation.
Yeah, I go off on a tangent. I say that all the time. So, oh, I went off on a tangent. Like,
I didn't know it was like real.
well, it is real. It's all real because we're real, miss. Okay. What would happen if we all just start like just bam, bam, bam? Okay. Yeah, that'd be crazy, right? The first rule of Fight Club. Yeah, there's no Fight Club. All right, here we go. So now we got the basics of secant, tangent, and normal. Are we okay? All right. So here we go. So the very first one, example, it doesn't have anything to do. Well, it does kind of. It says find the average rate of change of f of x equals x cubed minus x over the interval 1 to 3. So those are x values. That's an interval. So it wants the average rate of change. So all I'm going to do is f of 3 minus f of 1 over 3 minus 1. Does that make sense, guys? All I did was y2 minus y1 over x2 minus x1. Average rate of change. So they just want to know how much does my y value change when my x value changes by 1. It just wants to know the average rate of change. Sorry. Yes, y2 minus y1 over x2 minus x1. That's all I'm doing. Average rate of change. So here we go. I need an f of 3. F of 3 equals 3 cubed minus 3. 3 cubed is 27. Minus 3 is 24. And I need f of 1. F of 1 is 1 cubed minus 1, which equals 0. You okay, Gian? Okay. You sure? Well, this is my y value, right? When I put a 3 in, this is the output I get.
Oh.
So I haven't done this part yet, but I'm about to. So here we go. 24 minus 0 divided by 2. So what's my average rate of change? 12. 12 is the average rate of change between x equals 1 and x equals 3. So if I were to draw a line going through x equals 1 and x equals 3, that line, that secant line, would have a slope of 12. Are we okay? Nothing crazy? Let's go to the next. So here we have, it looks like number of flies on the y-axis and time. So maybe they're growing like flies or something. And it says use point P and Q to compute the average rate of change of the and the slope of the secant line PQ. So here's line PQ. Can you guys see it? And they want me to compute the average rate of change of that. And I know you can see it already in there, but let's figure it out. So I'm going to go 340 minus 150 over 45 minus 23. Do you guys have calculators? So I take my little calculator. I'm going to go alpha y equals to get the little fraction. 340 minus 150 divided by, and I already forgot what was in the denominator? 45 minus 23. And I push enter, and it's going to give me decimal 8.636. So that's my average rate of change. I already forgot it. 8.636. Flies per day. You always want to have units if there are units. Oh. So then they rounded that up to 9 flies per day. That's fine. It all depends on what you're working on. Nothing crazy so far. Pretty straightforward. ¿Cómo te sientes? How do you sit? ¿Cómo te sientes means how do you feel and how do you sit. Bam, you say you know Spanish? I'm kidding. I don't know why I'm violent. I'll stop. All right, here we go. Let's go to the next question. Now, look what this example says. Are we reading example 3? Wow, I should have put probably an example 2 in there, or like another one. Okay, that's fine. I have a function, 2x squared minus 6x minus 70 is graphed to the right with some secant lines. Determine the slope of the secant line of f for each of the intervals indicated in the table. Find the slope of the secant line of f on the interval 3 to x2 for each value of x2 shown in the table. Write your answer as decimals. All right. I don't know if you can tell because yours probably doesn't have it color-coded, and I didn't do a good job. I'm trying to remember where, this was Desmos or trying to screen capture. They might have been Desmos. So I have a whole bunch of secant lines here. And I'm trying to find my tangent line right at this coordinate, like my slope of that tangent line. And it looks like it's that red line there, almost, that red and purple line. So anyways, I want to figure out this slope, the secant slopes. And you can see 4, 3.1, 3.01, 3.01. You're getting closer and closer to 3. So eventually I want the tangent line at 3. Eventually I'm going to want a tangent line at x equals 3. Eventually. So this is one way to do it. So type this equation into your y1, and I'm going to do that. 2x squared minus 6x minus 70. So let me clear this. Clear. 2x squared. 2x squared minus what? Minus 6x minus 70? Okay. And I'm going to, let's see, what am I going to do? I'm going to go to the home screen. And here's what I'm going to do. I am going to do this. You see this right here where it says secant slope? I'm going to do this. I'm going to go f of 4 minus f of 3 over 4 minus 3. Whatever answer I get there, I'm going to put right here. How do I tell the calculator to do it? Like this. So let's all do it together. Ready? So I'm going to put the fraction feature first, alpha y equal enter. So does everyone know how to get a fraction feature? I think you could also do alpha, one of these here. If you have a new calculator, there's a shortcut like somewhere there. All right, here we go. How do I get the y value in, or the y1? Push alpha, trace, and look at all the y values you can choose. I'm going to choose the first one, y1. The trace button next to the graph. Did everyone get that y1? Open a parenthesis. Don't push the arrow yet. Put the number 4 and then close it. So that means evaluate y1 at 4. Now I'm going to push minus. And I'm going to call y1 again. Alpha trace y1. Open a parenthesis. Put 3 and then close it. So that means evaluate y1 at 3. In the bottom, you can put 4 minus 3 or you can put 1 if you want. Push enter. Did you get the value of 8? Yes. So I'm going to go back and I'm going to put 8. Here we go. I go back to my calculator. Yes. I'm going to do it again right now. So here we go. Ready? You know what? Let's do it from scratch. So I'm going to push alpha y equals. I push enter to get the little fraction. So I'm going to go alpha trace. I can choose all these. I'm using the y1 because that's the one where I have an expression. I push enter. And now I'm going to open a parenthesis. And let's see, what did they want again? They wanted it at 3.1. So I'm going to type in here, I'm going to go 3.1. Close parenthesis minus alpha trace. Enter. Open parenthesis, 3, close it. And in the bottom, you can either put 0.1 or put 3.1 minus 3. It does not matter. Ian, did we answer your question? Oh, I just wrote it. I just wrote what I'm doing, f of 4 minus f of 3. F is like your y on the calculator, y1. What did I get? I already forgot the number. What? 6 point what? 6.2. All right, I'm going to try 3.01. So I'm going to do it again. So I'm just going to go alpha y equals enter. Alpha trace. See, hopefully you're getting really good at this. Enter. Open parenthesis. 3.01 close minus alpha trace open parenthesis 3 close. Oh, did I mess up? I did mess up. Minus y1 open parenthesis alpha trace enter open parenthesis 3 close divided by 3.01 minus 3. And I got 6.02. 6.02. Someone give me the answer for the 3.001. What'd you get, Alvarez? Oh, you haven't tried it? Oh. It might. Oh, you just took an educated guess? Let's see. What do you mean?
Like, what you're doing, can you do it without the calculator?
Yes. But we're not there yet. Okay. Say it again, ask? Yeah. All right, guys. Any other questions? Flores. Oh, maybe you're not putting minus, maybe you're putting negative. You want me to look at your calculator?
No, I mean there's like a.
When you fell down the stairs, were you like,
No, I fell forward.
oh, did anyone help you up?
No, but
No one helped you out?
saw it and Natalie saw it.
You didn't help her out?
No, I didn't need help. I didn't fall down the stairs.
Were you laughing?
Yeah, it was
Oh.
embarrassing. I had to, you know.
Sorry, miss. I wouldn't have laughed. No, I would have laughed. I would have laughed. Okay. I probably would have. Yeah, you're right. All right, guys. Take a guess. Take a guess. What do you think the tangent slope is at x equals 3? What is it? Yeah, it's 6. It's approaching 6. That's that limit thing. See, so I could write limit as x approaches 3 of f of x minus f of 3 over x minus 3. And that will give you your tangent slope. All I did was y2 minus y1 over x2 minus x1, where we kept the f of 3 and f of 3 constant, right? X equals 3 and f of 3. Okay, are we okay so far? Okay, this, I'm going to put equals, and we got, like, it looks like it's a 6. Matter of fact, maybe we should try it out. We should do this limit with this algebra up here. You think we should? Okay, maybe not. Maybe not right now. All right. Yeah, we're going to go back to it. So look at this. So look, here's the first time that we're going to see it. So look, it says find the slope of the parabola y equals x squared at the point 2, 4. Write an equation for the tangent to the parabola at this point. Okay, so here's why calculus is so powerful. I want, and I'm going to exaggerate it, I want my slope, I want my tangent line at x equals 2. I want this tangent line. It's probably not drawn to scale, so that's fine. So here's how we're going to do it. You guys ready? I'm going to get super close to 2, and I'm going to use this notation. So I'm going to do it again, but I'm going to zoom in on it. So I have, well, I'll go through the order. You know what? It's that curve, but I'm zooming in. So here is 2 comma 2 squared is 4. And I'm going to get super close to it, like right, I have a point way up here, and that point is 2 plus h, comma, f of 2 plus h. And I want, what do I want? So right now I have a secant slope. I want this point, if I could drag it, I want it to hover over the 2. Does that kind of make sense? Like if I could drag this point, if I hover it right over the 2, won't I have a tangent line? Does that kind of make sense or no, guys? So here's what I'm going to do. You see how I have this as x1 and this as y1? And you see how I have this as x2 and this as y2?
Oh.
I am just going to do, I'm going to do this. I'm going to write the word limit. And then right now you're going to tell me what h has to approach. And I'm going to do f of 2 plus h minus f of 2. F of 2 is 4, by the way. That's f of 2. All over h. Where that h, let me go ahead and circle it. That h came from 2 plus h minus 2, right? That's just h. The 2's cancel out. Or 0 out. Have I freaked anyone out? Well, what do I want h to approach if I want a tangent slope? I want x approach 2. H is the difference in x. Yeah, I want this. Well, Chop, what is h then? I don't know what h is. H is the distance from this coordinate to this coordinate. The h is the displacement in x. That's h. H is your change in x. What do I want the change in x to be if I want my tangent slope at 2? Think, guys, think. My tangent slope at 2. What do I want delta x to be? No, if I choose 3, that's just going to give me my secant slope. I want it to be what? Yeah, you're right. Say it. 0. Why? No, say it. Just say it.
There's no thought.
Oh, you're fried? I don't think you're fried. But... Okay. So here's what Flores is trying to tell us. I want the tangent slope at 2, so you want h to approach 0 because then that secant line is going to start looking like a tangent line as h approaches 0. Don't worry, there's other ways to do it. You could do it like this. We could do it like this, and you'll get the same answer. Maybe that's the way you prefer. Chav, I want to do it that way. And look, doing it this way will get you the same thing. Limit, and I'm going to say as x approaches. Now this one, I want it to approach what value? If I go this route. You can say it, guys. F of x minus f of 2 over x minus 2. What do I want this value to approach if I go this route? Yeah, you said it. Say it again. 2. I want it to approach 2. Maybe you guys like this better. Like, Chav, didn't you just tell me that this will give me the tangent line? Yes, I did. Well, then that means, will this give me the tangent line at x equals 2? Yes, it will. I could go f of x, which is what we say, limit as x approaches 2 of x squared minus 4 over x minus 2. Can I do direct substitution? No. I expand it. Limit as x approaches 2, x plus 2 times x minus 2 over x minus 2. What's going to cancel? X minus 2's cancel. What's 2 plus 2? That's my tangent slope. Yeah, maybe I'm putting too many ideas together. All right. Well, both. We have to know both. We have to know both. Okay. Do you know how to calculate a rate of change? That's all I'm doing. y2 minus y1, y2 minus y1 over x2 minus x1, where I want x to approach 2. If I go, hold on, this is one route. If I go this route, the one that I just did right now, I have a coordinate. That point is 2 comma 4. And I have another coordinate, and that coordinate is x comma f of x. And, yeah, go ahead. Tangent slope. Yeah. Well, everything in aqua is related. So what I did right now is I said, look, these 2 points connect. That's a secant line. If I want a tangent slope right there at that moment, I just did rate of change. I went f of x minus 4, because that's what f of 2 is. I'll write it as f of 2 for now. F of 2 over x minus 2. That's just y2 minus y1 over x2 minus x1. And I just said limit as x approaches 2 will give me my tangent slope. We need to know both, but maybe I did too. Maybe maybe I should not have introduced both ideas. Okay, then let me erase everything. Yeah.
Okay, I just choose one and solve all of them the same way.
Yes, but you're gonna need to know both anyways, because the other one's gonna come out also.
Like there's gonna be things that we need to solve using only that.
No, there's gonna be things that you gotta recognize.
Oh, like in the tense.
Mm-hmm.
Well, we should do it.
It doesn't work now. Okay. Well, yeah, because I pushed a button. Okay. Here we go. I'm going to go slow, and we're just going to do it one way. We're not going to do it two ways. We're just going to do it one way. Once we get really good at that one way, we'll introduce another way. All right, one way, just one way. Here is my graph, and I'm exaggerating it. This is x squared. Are we okay with that x squared? Okay. I'm going to choose a point. They want a tangent at what point? So I'm going to go to that point 2, 4. Are we still okay? I'm going to go a little bit past that 2 to another point, and I don't know what that point is, but I am going to call it, I'm going to call this gap, I'm going to call that gap H. So this point right here is 2 plus h, where h is just the gap from this point to this point. Are we still okay? Okay. So what do I call this x coordinate? I'm going to call it 2 plus h. Are we okay with that? All right. What do I call that y coordinate? Well, I don't know. It's supposed to be some y value. I don't know that y value. I'm going to call it f of 2 plus h. Whatever that output is your y value. Are we okay with that? Okay. Have I lost anyone up to now? All right. So if I were to connect this to my algebra skills, to our algebra, we would say that's a coordinate, x1 comma y1, and we would say this is another coordinate, x2 comma y2. Yes or no? Okay. If I told you I want to find the average rate of change between these 2 points, you would say y2 minus y1 over x2 minus x1. Yes or no? So I'm going to write that down. I'm going to put average rate of change is, and I'm going to write f of 2 plus h minus, and then I can write 4. Can I write f of 2? Is that okay with you guys? Because I want to keep it consistent. Over 2 plus h minus 2. Ask. Don't worry, I see you, miss. Yeah, this is your y2. This is your y1. This is your x2. This is your x1. F of 2 is 4. F of 2 is 4 because that's my coordinate. F of 2, 4. I just wanted to write it f of 2 to keep it consistent with the literature you're about to see. Yes. All right. What's the question, miss? Oh. Because I want, yeah, you're right. How is this going to help at all? I want the slope of that purple line. I'm going to eventually move that point towards 2 by making h approach 0. See how the gap between this point here in purple and that point in purple is 2 and 2 plus h? If you make h approach 0, that point in purple will hover right at x equals 2. I'll go over there so I can... Yeah. See this point right here? If I were to drag it, h is approaching 0. The difference of h is h is delta x. If I approach it right, I put it right on top of 2. That'll give me that purple line. I know.
It's like an estimate of the line.
Well, if I get right on 2, it's going to be exact.
Well, doesn't that make like a project?
No. Well, it turns a secant into a tangent. Like right now, if I connect these 2 points, I just have like that. And as I get closer and closer, like that, that tangent starts to blend in. That secant starts to blend into my tangent.
Yeah.
So it'll be a brand new tangent. I'll find an example.
Are we trying to make it?
I'm trying to find just the slope of that purple line.
It's because what I wanted to do was. This is what I do. Like this is like the tangent. It just doesn't match with the curve.
Oh, tangent touches it right there.
Yeah, but like only at one point.
Yeah, correct. Only at one point. You're right. At the moment, it's not a tangent. At the moment, that's a secant. But if that point is right on top of the x equals 2, then it turns into a tangent.
Oh, okay, so it would be okay.
You know what I mean? Ah. Oh, you got me good. You got revenge for Alvarez. Alvarez revenge.
I was really in I said that we're gonna stab it.
All right.
When it comes in, I was like, I was glad to stab it.
Here we go. You guys ready? And I know, guys, this is tough. This is a hard concept to learn. But once we got it down, it will get easier, I can assure you. All right. So this is my average rate of change. Notice that the 2's zero out. And at the moment, that's, well, I'm calling that my average rate of change. But I want this secant slope, or this secant line, Really, it's secant slope at the moment. I want the secant slope, I want to turn that into a tangent. And if I drag this point, if I keep dragging it, all the way until I get to 2, that secant line will turn into a tangent line. If at 2, right? So what did I make h approach? 0. So I'm going to write, so here it is. I'm going to go slope of tangent. And it's always, you can always use this formula. It will always work. Slope of m of tangent, subscript tangent, is the limit as h approaches 0. We used to use delta x, but I think h is a better letter. Of f of 2 plus h minus f of 2 all over h. Okay, we're going to go slow. We already know what f of 2 is. F of 2 is 4. Now I need f of 2 plus h. So I'm going to come up here and I'm going to write the notes here. F of 2 plus h equals, parenthesis, it was x squared, so I'll write 2 plus h, close it, squared. Did I confuse anyone by writing that? Okay, I'll explain. The function f of x is x squared. This is my input. I can input whatever I want. I can say f of happy face and write happy face squared. I can say f of triangle and say triangle squared. So if I write f of 2 plus h, I write 2 plus h squared. Are we okay? Okay, here we go. I'm going to FOIL this. Here's the algebra. 2 times 2. 2 times h is 2h, but you're going to have how many of those? So I'm going to write 4h, and then h times h. All right, now we're ready. I'm going to come over here, and I'm just doing this limit right here. Equals limit as h approaches 0, and f of 2 plus h was that expression up there, 4 plus 4h plus h squared minus, and what was f of 2, Flores? 4. All over h. Are we okay? Now we're just solving this limit. What zeroes out? Once a 4's zero out, I can factor one of the h's, so I'll show it right here. Limit, let me write it in red. Limit as h approaches 0. Here's my h factored out. 4 plus h over h. What can I cancel out? The h's. And what is h approaching? So what's my tangent slope? 4. Yay or nay? Okay. You need 2 things for a linear line, for a tangent line. You need a point and you need a slope. What do I need? Do I already have a slope? Do I have a point? Yes, they give it to me, 2, 4. So what is my tangent line? And sorry that it's a mess right here. Here's my tangent line. Y minus your coordinate 4 equals slope 4 x minus 2. So I'll write the point slope form, guys. I'll write it right here. I did this. I did y minus y1 equals slope x minus x1. I prefer that one because you can leave it alone and be done with it. Now, I know you guys are like, Chav, I don't understand what you did of anything, any of this. Look at this. I'm going to go to Desmos. Do I have the internet on? Yes, I do. And I'm going to go to graphing calculator. Well, I guess I don't have, I could have done it with my TI-84. That's fine. I'm going to type in x squared. Y equals x squared. And then check it out. Give me that line that I just gave you guys. All right, guys, focus, focus. Y minus 4, was it y minus 4? Yes. Equals 4 parenthesis x minus 2. Look at this. Does that look like a tangent right at 2, 4? Yes. Yeah, it's a tangent line, guys. Cool, right? No, we're all cool. All right, so there it is. Now, if you want to write it in terms of y equals mx plus b, because I know you guys love that. You can distribute this. And here it is. Y equals 4x minus 8 plus 4, because I moved that 4 to the other side. Y equals 4x minus 4. This is your tangent line. Are we okay? Yeah. That's your final answer, because they just wanted a tangent line, right? We're going to practice together again. So look at this. And don't worry, we're starting with small parabolas. So look, it says, write an equation of the tangent to the curve, 4 minus x squared. We're going to go slow, guys. We're going to go slow. At x equals 1. Do you know how this graph looks? Vertex at 4, or 0, 4, and it opens downward. And it wants a tangent at 1. So here's my tangent line, and it should look something like that. Yay or nay? Okay. So, what two things do I need if I want a tangent line? I need what and what? Point and a slope. So let's get the point first. What does x equal? So I'm going to write f of 1 equals 4 minus 1 squared, which is, what's 4 minus 1? So I have f of 1 equals 3. There's my point. Now I need a slope. Chop, how do I get your slope? We're going to get the slope the same way every time. M of t stands for tangent. Limit, as h approaches 0, f of 1 plus h, because that's where I wanted it. I wanted it f of 1, minus f of 1 over h. All I did was y2 minus y1 over the difference in x, which is h. The formula is going to look the same all the time. What's up? Yes, because I want a tangent line. You want your delta x to approach 0. H is delta x. H will eventually always cancel out, yes. Yeah, your H is not going to cancel out initially. Eventually, the H's will cancel out.
No, that means like now, like when you're writing that, you assume that it's you start off that way.
I always start off that way.
Did that.
Yes.
Okay.
Okay. Yes, we start off this way. Always. Yes.
So that corner is 1, 3.
Yes, this corner is 1, 3. Okay, you guys ready? Limit as h approaches 0. Okay, I want to understand your question because now it's bothering me. Can you tell me again? I know she already answered it, but...
Yeah, no, but it makes sense. So, like, okay. No funny business. Like, okay, we already know that like, the plus 1 and the minus 1 are cancel out, so that's what it is.
Yes, yes. That's why I just write h. 1 plus h minus 1. Yes. Sorry, miss. Yeah. I didn't catch you the first time, but yeah, that's why we just write h, because x2 minus x1, the numbers are always going to cancel. Yes. Always, always, always. Yes. Thank you. All right. F of 1 plus h. Oh, I don't have f of 1 plus h yet. Okay, here we go. No big deal. Go to the side, and I'm going to write f of 1 plus h equals, and I'm going to write 4 minus, open parenthesis, 1 plus h, close it, squared. We got to expand it. So here's your algebra. 4 minus, open parenthesis, 1 times 1 is 1. 1 times h is 1h, but when I add them, there's 2 of them. When I add them, it's going to turn into 2h. And h times h is, perfect. Distribute. 4 minus 1 minus 2h minus h squared. And no, right now we're being slow because we want to show every step, but eventually once you get really good, you can just go right into the answer. What's 4 minus 1? So 3 minus 2h minus h squared. That's my expression for f of 1 plus h. Are we okay? Okay. Have I lost anyone? All right, I'm going to come back to my limit. Limit as h approaches 0 of 3 minus 2h minus h squared minus, what is f of 1? 3. All this is over h. What zeroes out? The 3 zero out. Now that I've zeroed out the 3's, can I factor out an h? So I can cancel one of those h's with one of those with one of those. I don't want to show that step, guys. So I just did this right here. Now what is h approaching? 0. So I'm just gonna have -2. You have -2 minus h, but h is approaching 0. So direct substitution. Oh, f of 1 is 3. This one's f of 1. We're still okay? We're doing good. If you get a positive slope, you know that something's off because look at that tangent line. That tangent line is negative. The slope is negative, not the... All right, here we go. All I need to do is write it in point slope form. Y minus, what do I put? Y minus 3 equals, what's my slope? -2, open parenthesis, and then what do I write in there? Perfect, there it is. This is your tangent line. You can actually leave it like that, and it will be kind of correct. You can type it like that in Desmos. Let's go ahead and write it as y equals mx plus b. Y minus 3 equals -2x plus 2. Move the 3 to the other side, so plus 3. Y equals -2x plus 5. It doesn't, if it's free response, you can leave it like that. So let's test it with Desmos. Yes. Y minus y, okay, I'll write it right now. Let me just do this really fast. Y equals 4 minus x squared. And what was my tangent line? Y equals what? -2x. And let's see if it really goes to that 0.13. And look at that. Does that look like a tangent? Yes, it's a tangent. Okay, the point slope form is y minus y1, right there in black. Slope x minus x1. Where x1 and y1 is a coordinate. Now, if you type this into your TI-84, don't freak out. The window is not squared, but it is tangent. Watch. Let me look. Here's my TI-84. So give me the one that we were just working on, 4 minus x squared, and give me that tangent again. -2x plus 5. Now, at first glance, so let me make the window. Let me make a standard. So at first glance, you're gonna look at it and you're like, well, actually, that kind of looks like a tangent. Yeah, but if you square the window, sometimes it won't look tangent. So sometimes you got to square the window, guys. So number 5, square, and there. That's well, it actually looks worse, but that's fine. Sometimes you got to square the window because it. Okay, watch. Check this out. I think the next question asks for a normal line. Does it? Yeah, because I typed these notes out. So, all right. So look, here's what I mean. We'll put it on Desmos and we'll put it on the TI-84 and you'll see what I mean. So write an equation for the normal line to the curve. All right, so what do you need to find a normal line? Just a point and a slope. I already have the point. You already have the slope. Remember that the normal line is perpendicular to the tangent. So my normal slope, if my tangent slope was -2, your normal slope has to be half. I'm just going to write y minus 3 equals 1/2 x minus 1. It's the same point, guys. Distribute. Y minus 3 equals 1/2 x minus 1/2. Plus 3 plus 3. Y equals 1/2 x minus, plus 2.5, 2, 4, 5. 5/2. Opposite reciprocal, yes. Always for normal. Yeah, we can write 2.5. 5/2 is the same thing as 2.5. I just want to be consistent. If I write a fraction for 1/2 x, then I want to write a fraction for the y-intercept. All right, check this out. Don't worry, I see you, miss. If I type this into Desmos, Desmos has no issue. It's definitely gonna look like a normal. I'm writing everything bad. Y1 equals 1/2 x plus, I'm going to write 2.5 to make it fast. Check it out. Does that look like a normal? Yeah, you can put a stick of paper in there. Look, this is 90 degrees. And I didn't forget, someone has their hand up. Oh, that's 90 degrees. Now, if I type, don't worry, I haven't forgotten this. If I type this into the TI-84, so look, it may not look like a normal line. Give me that equation again, 1/2 x plus 2.5, and I'm gonna put it standard. So here's how it usually looks, number 6. Yeah, see how it doesn't really quite look like it's a normal line? It is though. It's just because this window is not a square window. So now look, if you go to zoom and you see the one that says square, it's gonna square my window, and now it will look like a normal line. Well, there's squigglies. There's something going on with how accurate I'm putting it in my calculator. But it looks a lot better now. Now that does look like a 90 degree.
You're like, it's gonna look totally normal.
Well, let me look at what's going on with mine. Yeah, that's actually the first time it's done that, so it's probably something with my trace, with my step. Okay, what was the question, Espinosa? H? Okay, say it again. It's because I was trying.
Are all these equations for the tangent, all of them, for now we're just working on it?
H approaching 0, yes. Yeah, because we're looking for tangent slopes.
Is it possible to be others?
Well, for now, remember we said that we just want to work with 1. So for now, H is going to approach 0 all the time. For now. Until we get really good. All right. How do we feel, guys? All right, let's go to the next page. I try, miss. I try really hard. Did we learn? Are we learning? Okay. Example 6. It says, oh, Gian, you doing okay? You doing okay? Gian? Did you say huh? Oh, no one said oh, okay. Limit as h approaches 0 of f of t plus h minus f of t over h for the function at t equals 2. Interpret the answer if f of t represents position function in feet. I love it. And time is in t in seconds. Okay, before we even do this, remember what we're finding. Remember what we're finding. This is a rate of change, yes or no? Because h is approaching 0, that means my change in time is approaching 0. So this we call instantaneous rate of change. Yeah, no, don't put it in an acronym. Just write the whole thing out. Instantaneous rate of change. So this is why you couldn't do these type of problems in your physics class if you didn't have calculus yet. Now, if this represents something in feet and time in seconds, what type of units will this give me? Yes. It tells me here, interpret the answer if f of t represents a position function in feet and an object at time t seconds. So if f of t represents my position in feet and t represents time in seconds, what does this give you? Feet per second, instantaneous rate of change. Does that make sense? So this will output feet per second. That will output feet per second, guys. Right? Yes. You remember instantaneous rate of change? That's what this is. It's at a moment. That's what that is. So what is, all right, again, focus. What is an instantaneous rate of change? Maybe you guys are like, I don't know, I've never heard of that. I just know what a rate of change is. An instantaneous rate of change is what's the rate of change at that moment. You experience every day. Every day you guys either ride a bus, a vehicle, or maybe you ride a bicycle. At that moment, what is your speed? When you're driving your car and you look at your odometer, at that moment, that's an instantaneous rate of change. That's just at that moment. So when you look down, it says 73 miles an hour. That's how fast you're going at that moment. When your car tells you your average speed, when you click a button, oh, your average travel is 45. That's your average rate of change. But when you look down at your odometer and you see the speed, That's an instantaneous rate of change. Are we cool? All right, here we go. We're going to find this. Oh, ask, please. I want you to, miss.
So basically, the instantaneous is like
At that moment. So at what moment? Look at this. At t equals 2.
Okay.
So at that moment. All right, here we go, guys. You guys ready? I need to do this guy at t equals 2. So here we go. Limit as h approaches 0 of f of 2 plus a little bit past it, so 2 plus h minus f of 2, all divided by h, because the 2 will cancel out. 2 plus h minus 2. And I want h to approach 0, so that's why I wrote h approaching 0. Are we okay so far, guys? All right, here we go. On the side, I'm going to figure out what f of 2 is. So I'm going to write f of 2 equals 2 times 2 squared minus 1. What's 2 squared? 4 times 2 minus 1. So there it is. F of 2 is 7. Now I need to figure out what f of 2 plus h is. And I'm going to go slow. 2 times 2 plus h, close it squared, minus 1. Equals 2, parenthesis. What's 2 times 2? 4. Plus, what's 2 times h? 2h, well, you're going to have 2 of them, so you're going to have 4h plus, what's h times h? H squared, close the parentheses, minus 1. Distribute the 2. 2 times 4 is plus 8h plus 2h squared minus 1. You're so close. Once you start doing this many times, you can start just doing, like skipping steps. What's 8 minus 1? So 7 plus 8h plus 2h squared. If you have the habit of writing the 2h squared in the front, that's fine, no big deal. It's not a big deal. All right, here we go. I come back to this. I'm going to put an equal sign. I'm going to rewrite it again. Limit as h approaches 0, and I'm going to write what the expression f of 2 plus h is, and it's this one right here. 7 plus 8h plus 2h squared. And I'll wait for you guys to catch up. Minus, what is f of 2? 7. All this is over what? H. Now don't go canceling h first. We first have to zero out the what? 7. It's always going to zero out. If it doesn't cancel and you have terms that, if you have like a number somewhere up there, you can't cancel out the h's because you got to do that first. Now that I have h's on top, I can factor out an h, yes or no? So I can cancel one of those with one of those with one of those. What is h approaching? It approaches 0, so I'm going to have 8 plus 2 times 0, which is 8. Yes, I need units. Good job. What are my units? Feet per second. So whatever this is traveling 8 feet per second at t equals 2. Does that make sense? All right. Look at example 7. Oh, I love example 7. A rock breaks loose from the top of a tall cliff. The position of the rock is f of t equals 16t squared feet, where t is in seconds. This formula does come from somewhere, guys. It didn't magically appear. We're going to talk about that right now. What is the average speed during the first 2 seconds of fall? Okay, before I even continue, when you were in physics, the acceleration due to gravity in feet per second squared is 32 feet per second per second. That's if you're in America. Actually, it's everywhere, but American units, feet per second squared. The whole other world, the rest of the world uses, do you remember? Starts with the number 9. 9.8, yeah, negative 9.8 if you say gravity is down. Negative 9.8 meters per second per second. So I like to say 9.8 meters per second because the way I interpret it every second you increase your velocity by 9.8 meters per second. So if you tell me 9.8 meters per second squared, I'm like, well, what's that? You know, like, does that make sense? So you'll see a lot of times mathematicians will write meters per second, but physicists, they don't care about units. It's meters per second squared, whatever. That's fine. It doesn't matter. Okay. The equation, let's see if you guys remember. The distance that you've fallen is equal to the velocity initial times time. That's via, you know what, let me just put t then. Plus 1/2 at squared. Do you guys remember that? Okay. So look, where did that equation come from? Well, they're using feet per second, so that means they're using acceleration as feet per second squared. Velocity initial is 0, so 0 times, because it breaks off, right? It's a rock that breaks off, so velocity initial is 0. That makes sense or no? Yeah. So if I plug in that 32 for A, what's that for 32? 16t squared. That's where they got it, see? That's where they got that f of t equals 16t squared. So don't freak out. Are we okay? The 32 feet per second squared and 9.8, those are just given. It's understood from laws of gravity. You know what I mean? Yes. So what's the acceleration in America? Well, it's actually the same everywhere, but in American units. Yeah. No, acceleration. Give me the units. Give me the number. Don't worry, I'll give it to you. Ready? 32 feet per second per second. Okay, now you tell me. What is that? Due to? Yes. What is it in metric units? Yeah, you do. Starts with a 9. Yes. Okay. Do it again. What are my units due to gravity in American units? I don't think it's called American. Okay, what is it in metric? Good job, you got it.
So we use that when things are falling?
Yes, on Earth. Because sometimes things fall on Mars and they have a different gravity. Or in the moon. Okay. All right, here we go, guys. You guys ready? This was the type of questions that Mr. Winters asked you last year, because this does not require calculus. It says, what is the average speed during the first 2 seconds of fall? So all you know, you're like, well, Mr. Winters told me that average speed is just displacement divided by time, or distance divided by time. What, right? That's how he talks? No? Okay. How does he talk? Is he very proper? Well.
How would you not know how he speaks?
That's exactly how we say it.
Yeah, but the way he teaches and the way he talks is different, right? So when he teaches, he's probably very proper. He's like, well, what is gravity?
Yeah. You'll like ask
He
me
keeps his hands
change
here.
the accent. Down.
How do I, like more white?
Just like
Yes.
more white. He was like,
What is gravity?
not countrywide.
Oh, I don't know what I can do for it. Okay.
American.
Oh, what are you trying to say? I'm American. Yeah. All right. Sorry, guys. Sorry. Here we go. That's enough fun. We can't have fun in this class, guys. Come on, you know that. All right, here we go. Stop. All right, guys. Mr. Winters, if you're watching this, like, it's all with love. All right.
Everyone like recommended.
Here we go. It's at the 11-minute mark. I mean, it's 11:01 mark. If you want to get. All right, here we go. What is the average speed in the first 2 seconds? Well, I need to know how much distance I've traveled. So you're going to do this. You're going to go f of 2. That's going to tell me my position at 2 seconds. Minus f of 0. All over 2 minus 0. So there it is. Distance divided by time. Yay or nay? All right. On the side, I'm going to go f of 0 is 16 times 0 squared. So you just get 0. And f of 2 is 16 times 2 squared. 2 squared is 4. 16 times 4, I believe, is 64. Well, let's see. 16, 32, 60. Yeah, 64. No, you're good. Maybe you're giving me the answer already. So 64 minus 0 divided by 2. What's 64 divided by 2? So this is my average speed. Give me units. Feet per second. So this rock, the average speed in the first 2 seconds is 32 feet per second. That's what you did in physics. Now here it is with calculus. Ready? This one says, what is the speed of the rock at the instant t equals 2 seconds? So before I even start, what do they want? They don't want the average speed. They want the, what did we call it? Yeah, so we can call it instantaneous speed. Instantaneous, man, can I spell that? Instantaneous speed. You can also say rate of change. Are we okay? So now we need calculus for this. So here's how you do this. You got to write the word limit. Limit as h approaches 0. of f of 2 plus a little bit past it minus, I want it at what time? At t equals 2. So I put a 2 on this one. See? 2 plus a little bit past it and minus f of 2. So we're going to get it right at 2. All divided by h. Have I confused anyone with that expression then? Okay, so everyone knows why we put the 2 in there, right? This is the 2 plus h is a little bit past 2 seconds, but remember h is approaching 0, so minus f of 2, this is going to go back to at 2, right at 2 seconds. Cool or not cool? All right, here we go. On the side, I already know what f of 2 is. There's no reason to do that one again. F of 2 is 64. I'll just write it right here. I need to know what f of 2 plus h is. So I'm going to write f of 2 plus h equals 16 times 2 plus h, close it, squared. Am I okay so far? All right, here we go. Let's expand it. Equals 16 parentheses 2 times 2. 4. 2 times h. 2h, where you're going to have 2 of them, so it's going to be plus h times h. Distribute the 16. 16 times 4 is plus 64h plus 16h squared. Are we still cool? All right, then I come back to my limit, and I write limit as h approaches 0, and I'm going to write this expression, 64 plus 64h plus 16h squared minus 64. All this is over h. What zeros out? You always zero those out first. You cannot factor out an h without zeroing those out first. Next, now can I cancel out one of the h's? Yes, you can factor out an h, so one of those with one of those with one of those. I just didn't show the factoring out, but you factor it out. Now, what is h approaching? 0, so that means 16 times 0, so what do I got left? And I need units. Feet per second, just feet per second, it's speed. So what does that mean? Right at t equals 2 seconds, this rock is falling at 64 feet per second. Cool or not cool? All right, let's go to the next one, guys. We gotta get better. Yes, you could have done it like that without calculus, but making sure. All right. No, but you know what I mean. Obviously, we put simple ones here first, right? But all right, here we go. Example 8. Look at this, guys. The equation for free fall at the surface of Mars is. So that's the equation of free fall in Mars. This is in metric, in meters with t in seconds. Assume a rock is dropped from the top of a 200-meter cliff. That doesn't matter. Find the speed of the rock at t equals 1 second. Okay, 1 instantaneous rate of change. You guys ready? So I need, what do I need? I need s of 1, and I need s of 1 plus h. Does everyone know why I'm looking for s of 1 and s of 1 plus h? Because we're looking for the instantaneous rate of change at 1, right? Okay, s of 1. 1.86 times 1 is just 1.86. S of 1 plus h. Let's see if I can fit it here. 1.86 times 1 plus h squared. There's a square on the t, right? All right, equals 1.86 parentheses 1 times 1. 1 plus 1 times h. 1h, but you're going to have how many of them? Bless you, 2 h's. Plus h times h. H squared. Close it. Now I'm going to distribute the 1.86. So I'm going to have 1.86 plus, I don't know if I can do that real quick. 1 plus 1, 3, and 5, 6, 7, 8. Oh, you guys tell me. 1.86 times 2, what is that?
3.72.
What is it?
3.72.
3.72. Just 3.72, that's it? H plus 1.86 h squared. Are we okay? All right, so then I'm going to write speed at t equals 1 second equals, and I'm going to write limit. Always write limit as h approaches what? 0 of this expression. 1.86 plus 3.72h plus 1.86h squared minus 1.86. All this is over h. What's going to zero out? 1.86. What can I cancel out or factor out now? One of the h's. Bam, bam, bam. Equals. So 3.72 plus 1.86 times h. Now I can do direct substitution. So I'm just going to get 3.72, and I need units. Meters per second. How do we feel? Okay, can we take some more, guys? All right, these are just now practice questions for you guys. So it should go pretty smoothly now. Sorry that it's taking a while. All right, number 1, true or false? If the graph of a function has a tangent line at x equals a, then the graph also has the normal line at x equals a. True. If you have a tangent line, you have a normal line. If you can dodge a wrench, you can dodge a ball. That's from a movie, but I don't remember the name. Dodgeball, actually, yeah, I do remember. It's really funny. Yeah. No, not Ben Stiller. Huh? Oh. Yeah, true. All tangent, yeah. Tangent lines and normal lines are perpendicular to each other. Tangent. Or you know what, just the justification can be normal lines are perpendicular to tangent lines. Normal lines are perpendicular to tangent lines. Perfect. Thank you for being specific. All right. True. Normal lines are perpendicular to tangent lines all the time. All right. Number 2. Find the average rate of change of this function. You guys ready? No calculator. Average rate of change. Do I need limits for this? No limits. You just go f of 3 minus f of 1 over 3 minus 1. So I go to the side. I choose what f of 3 is. 3 squared plus 3. 9 plus 3, what's that? 12. And then I go f of 1. 1 squared plus 1. So that's 2. So then I come back over here. 12 minus 2 over 2. 12 minus 2 is, and 10 divided by 2. That's my average rate of change. So the answer is letter E. Oh, sorry, miss. Too fast, too furious. We're just quoting movies here. What's the next movie, you know? Nemo, where? Okay, I'll stop. All right, here we go. Which of the following, and I'm going to go slow on this one, so this one I'll go slow. Which of the following is the equation of the tangent to the graph of f of x equals 2 over x at x equals 1? If I'm finding a tangent line, I need two things. What and what? Okay, a slope and a point. Let's get our point first, because that we can do really quick. F of 1 equals 2 divided by 1, which is just 2. So now I got my point. 1, 2. Now I need to get a tangent slope, correct? So I'm going to go slow, guys. Here you go. I'm going to go slow. Limit as h approaches 0. And I guess before I start, I need f of 1 plus h, right? So on the side, I'm going to go on the border. I'm going to use the margin. F of 1 plus h equals 2 over 1 plus h. And there's nothing you can do about it. Just leave it alone. So limit as h approaches 0 of 2 over 1 plus h. Relax. It's not, don't freak out. Minus 2. And all this is over h. Chop, I've never seen this before. I can't do it. Yes, you can. It's just algebra. I need to have a common denominator, and they're forcing me to use common denominator in the numerator. You see how I have 1 plus h here? All I got to do is multiply this sucker over here by 1 plus h over 1 plus h. So that's just 1 there like that, right? So here we go. Limit as h approaches 0, 2 over 1 plus h minus, and then you can distribute that 2 there, 2 plus 2h over 1 plus h. All this is over h. Are we still okay? And to help you out, if you want to put parentheses on the numerator like that, because we're going to distribute the negative, you can. That way you don't mess up. Limit as h approaches 0, and I'm going to put everything together, guys. 2 minus 2h over, I'm gonna put the h first. H parenthesis 1 plus h. I did keep change flip. I just brought that h up. I just brought the h up, guys. Keep change flip. Are we still okay? Yeah, that's why I asked if we're okay. Oh, sorry. All right. I'm going to zero out first. What can I zero out? These two specifically, not the two with the h. Now, what can I cancel out now? One of these h's is one of those. Now, can I do direct substitution? Yes. You just get negative 2 over 1, which is just negative 2. That's my slope. And I already have my point, right? So here we go. On the side, I'm going to go y minus 2 equals negative 2 parenthesis x minus 1. Close it. Now all I got to do is make it look like those A, B, C, D, E. See which one it is. I'm going to distribute that negative 2. So y minus 2 equals negative 2x plus 2. And then move that negative 2 to the other side. So we're just going to add 2. So y equals negative 2x plus 4. Look for that. How do you feel right now, guys? Yeah. We got one left. There's the last one, guys. Last one. It wants the same, it's the same equation, but it wants the what? The normal. So all I got to do is change the slope. Y minus 2 equals what's opposite reciprocal of negative 2? So 1/2 parenthesis x minus 1. Close it. Now just solve for it. Y minus 2 equals 1/2 x minus 1/2. I'm going to move that negative 2 to the other side. Y equals 1/2 x. 2 minus 1/2 is 1.5, which is the same thing as 3 over 2. What's the answer? Yeah, you're right. That's right. Was today's lesson okay? Did we get a lot of good stuff? All right. I'm not going to add any homework. Just finish up your UH quizzes. We'll do deltas tomorrow on this because right now I want you to just focus on whatever. Test when? Did I never told you guys? Tuesday when we come back. That gives you time. That gives you time to.
Oh, I forgot about that, right?